Yes, sir. Yes, sir.
Okay. Sorry, today my venue changed a bit, so it's. I mean, I just some. We'll just start in a couple of minutes because I messaged I WhatsApp saying that I will start 5 minutes late, so we'll just wait for a couple of minutes and start.
Okay, sir.
Thank you. Sit here. Okay. Okay, so let's start today's class. So last class we were looking at SIB1 messages. Okay, we were looking at SIB decoding. Okay, the core set 0 decoding. Okay, so what we have learned till now is the location and the placement of SIB messages. Rather the core set 0. Okay, so what we should remember is once you decode your MIB using the SS block, you will know the location of core set 0. Okay, so core set 0 is nothing but it is the control information that points to the actual location of the SIB1 message. Okay, so remember this. Okay, so I'm just going to write this in a slide. This will become much more clear once we do control information. So essentially, core set 0 has the control information for SIB1. Okay, so SIB1 is in PDSCH. Okay, and core set 0, which is the the PDCCH, provides the location of SIB1 in PDSCH. Okay, core set 0 by itself doesn't have SIB1; it has a location of SIB1. Okay, you should remember that. Any question before we proceed? Okay, so today what we are going to do is, can one of you confirm am I audible?
Yes, sir, you're audible.
Okay, thanks. Sorry, there was no feedback, so I just okay. So today what we will look at is we'll look at two things. One is we'll look at what are the contents of SIB1. See, SIB1 is one of the most important control information that comes from the base station to the UE. Okay, so we look at the important parameters of SIB1. Some of the important things. There are lots of things in SIB1. Some of them may not be relevant to us. And I'm also not very fully aware of all the RRC parameters in SIB1. So what we'll do is we'll look at the important things that are necessary for us to proceed further. Okay. So from a high level perspective, Okay, so essentially, whatever is the information is there in the SIB1. So essentially, what you did once you didn't decode the MIB messages, you know the core set 0 location. Core set 0 location. Core set 0 is nothing but the control information. Okay, so that is polar encode and other things. You decode the core set 0. Once you decode the core set 0, you will know the location of SIB1 in the normal downlink shared channel PDSCH. Okay, that is the procedure that happens. And then you go ahead and decode the SIB1 message in the PDSCH. Okay. And so effectively what happens is in PDSCH, in the SIB1 messages, there's a lot of control information. The most important thing from at least our perspective is PRACH information that will be there, where uplink transmissions can happen, some things about the TD configuration, and some things about the frequency configuration. Okay, these are the 3 important parameters. We'll go through this in some detail now. And then, after that, I mean, there are so many other parameters which we can look at based on need-based approach. Okay. So SIB1 is transmitted with a periodicity of 160 milliseconds. Okay. So that's what happens. So the UV might always look for SIB1, but it is the SIB1 itself is transmitted at 160 milliseconds, and inside a particular, there may be some other repetition periodicity. What do you say? I mean, for us, let's assume we can do it in 160 milliseconds. Yeah. Okay. This is what I was telling. The transmit in PDSC is the scheduling which is done in core set 0. Okay. Again, we look at the core set 0 is something called as format 10. We'll look at this in great detail when we do control channel. Okay. Okay. So all we have to remember now is in the core set 0, the location, the time and the frequency location of SIB1 in PDSCH is given. Yeah, that's all we should remember now, as of now. Okay. So what are the contents of SIB1? Okay. SIB1, I mean, as I said, is the first, I mean, after MIB doesn't have too much control information. First, I mean, system, I mean, a lot of cell information is provided in SIB1. Okay. So one is called, so these are the different information that is provided by SIB1. I'm not going to read them. So you have the cell selection information. I mean, for example, IMS emergency support. I mean, some of them I don't even know what they are. I mean, for me, most important things are the first 5 things, 1, 2, 3, 4, 5. The other things are more or less about emergencies. I mean, who can use the cell, who cannot use the cell, bearing information, and yeah, I mean, I don't know what is eCall over IMS support. Okay, so these are some other things that are there, but I mean, they're not very critical for us to go forward. Okay, the most important things for us are in the first few this thing. Okay, so if you look at the SIB1 RRC message, this is how it looks. Okay, so this is the SIB1 message that's goes. Okay, so the first thing is the cell selection info, then is cell access related info, and connection establishment failure control, scheduling info, serving cell config common, then followed by a bunch of other things. Okay, bunch of other things which are not very critical to our things.
Sir, may I know what is this, sir? Some few of last few weeks also you are showing this one.
RRC parameters. Oh, what are these? Okay, fine. Hey, so one more thing. Today I will not be able to look at the chat or anything because I have only one computer. So please speak up if you have any question. I cannot. If you have any question, just switch on the mic and talk. Okay. So what are these I am talking about? So these are the RRC parameters in 38331. Okay. I have shown you this before, but let me just open. These are 38331. All the RRC parameters, the control information parameters, are put on this. Okay. So this is the set of all the parameters that the base station sends to the UV. Okay. It's a lot of parameters are there. Okay.
No, so sir. My question is it a program or what? Because it's showing start and sequence.
Yeah. So okay. This is called ASN language. This is a specific language. Okay. So this is a specific language called ASN. I forgot what is the full form of ASN. Okay. So it's called an ASN language. It's a compiler for this. So what happens is, so what I'm going to do is, I'm going to actually ask someone from my L2 team, I mean, not my team, someone from an industry person to teach you about this ASN language a little bit. One class I'll ask him to do. Okay. Not right now, but later. Okay. He will tell you exactly what this is. So what happens is, this is in a text format. Now this gets compiled into bits, and only the bit streams are sent as control information from the base station to the UV. Okay. So for example, If you see my cursor, it says QRX min on offset, integer 1 to 8. So essentially, it's very obvious that this parameter is an integer from 1 to 8. So when it's an integer from 1 to 8, it takes 3 bits. Okay, so there are 3 bits for this. So what happens is, essentially, this is what is called as signaling information. Okay, so the signaling information happens in a very, very particular format in this particular kind of structures. Okay, so from our perspective, what we will just look at the text and try to understand. But actually, what happens is this is converted into bit sequences and transmitted. We will actually do this. I mean, I will ask the expert to come and teach you on a class on how do you compile this into bits, what exactly does this particular optional, need S, need R, and all those things mean. But more or less, it's obvious. Now, it's for example, IMS emergency support, enumerated. Enumerated means it's true or false. So it's 1 bit. Okay, and there's something like sequence. Sequence means essentially it's a set of these kind of structures. Okay, I mean, it's more or less obvious when we see this what these are. Okay, that's why I was not paying too much attention to that. Okay, so this is called ASN. Okay, for just I'm going to write this here and erase this. It's called ASN. You can check this in Wikipedia. ASN for RRC, if you type, you get a lot of pointers. Okay. Okay. So, is it fine? I don't know who asked the question actually.
Yes, sir. It's okay.
Okay. So we'll go into some detail on that. Okay. So this is what is called a signaling information. Okay. So the first thing. So you see a bunch of structures. Yes. So the first thing is the cell selection info. So essentially, this is a sequence of bits that are sent as SIB1. Okay, so based on how these bits are populated, you'll understand what is each of these values. Okay, so the first thing is a cell selection info. There's a sequence. There is something called RX min, min offset, RX SUL, quality min, qual min offset. Okay, and then there's cell access info, connection establishment failure, schedule SI, system information, scheduling information, serving cell config comment. Okay, I'm going to focus on all this. There are other things also which I'm not going to focus on. So let's start with the cell selection information. Okay. Again, we will do this in detail when we do the measurements. For now, what you should understand is, if you look at the cell selection info, there are 1, 2, 3, 4, 5. Okay. One is something called RX min, then min offset, this thing. So what are these mainly done is used is, so you may decode multiple cells. You may decode multiple cells based on your MIB. Okay. The question is, what cell are you going to lock on? Okay. So what this is going to do is, so essentially they are going to do something called as RX11, SRX11 and SQual. Okay. The one is the quality indicator and one is the resource RX level, the actual received power. Okay. They compute this. So this is what you measured, and these other parameters are what you get from RRC, from your SIB1. This one, this one, this one, this one, all these other things you get from SIB1. Once you get this from your SIB1, you look at your measurements and then you see, you compute these two quantities. And you select that particular cell if both of them are greater than 0. Okay? So this is called a cell selection information. So every cell, of course, transmits its own MIB and its own SIB1. So every cell can set these parameters appropriately. And a UV selects only those cells for which this is greater than 0. Once it has multiple cells, then it has some other criteria to select. Okay. For now, one of the parameters I want to tell you that these parameters are used to understand what is whether you latch onto that cell or not. Is it fine?
Sir,
Please.
Sir, in 2G, good strength indoor coverage, in-car coverage like that, specific kinds of coverage, 65 dBm is indoor outside coverage. Indoor coverage is some 94 dBm. Like that, thresholds will be there. So beyond that, it will not be latched. So here, do we have any kind of...
so these are the thresholds. These are the thresholds. So those thresholds are set like this. I'm not very sure of what is RX11 qual min. We'll do this when we do power control. I will tell you this. Okay, I'm not very sure on what is the difference between both the quality and the RX level when we do power control. But what I want you to remember from this point is these thresholds are cell based and they come from your SIB1 messages.
Okay.
Okay. And then there is this, okay. And the next parameter in this is called the cell access related info. Okay. So what is the cell access related info? So the cell access has all the, so these have what you call as PLMN IDs of the, the base station. Okay. So it has PLMN ID, it has MCC, MNC, RAN area code. So, the people from DOT are familiar with this now. What is MCC? What is MNC? One is the country code and one is the network code. Yes, MCC and MNC. Okay. And similarly, there's a RAN area code. You can put one more RAN area code, the cell identity. So essentially, this particular thing that comes from SIB1 message helps you to identify what is the base station, which country code it is, what is the network it is. So this part, all of them come from this cell access related info. Okay. So I put a link. If more, I'm not going to go into. I'm also not very an expert on what is PLMN IDs and other things. But these PLMN IDs are used to select networks. Okay, there's a particular algorithm for this. These PLMN IDs. So your SIM card has a specific ordering of multiple PLMN IDs. Okay. And once you do a scanning of different SIB1s and you latch on to a few of the SIB1s, then based on what you latched on and what is programmed in your SIM, there's a specific order in which PLMN IDs are arranged, and you choose the one with the highest priority. Okay, that's what happens in general. I'm just telling you a small part of this. Okay, but this is very, very critical for people who are looking at configuring a network. So this PLMN ID is kind of give you a unique identifier for a particular base station. PLMN ID along with your RAN area code gives you a unique identifier for that particular area. Okay, so I put a link here. So those of you who are interested can look at this thing. Okay, so again, so you understand. So this is the first time you are receiving all this information from SIB1. Okay, so the once you receive the cell access info related info, you can understand which country you are in, which network you are in. All those information will be there. Is that fine? Okay. So then there's the third thing is called the connection establishment failure control. So what this says is, essentially this talks about, until effectively it's about reconnection. Okay, it tells you if you are not able to decode your not SIB1 messages, the other messages after SIB1. The SIB2, SIB3, and SIB4, I'll tell you that later. At what point you do time off and you do reconnection again. Okay. Again, these are not very critical to our course at this moment, but those of you who are interested should read this again in more detail on this particular website. Okay, I put this thing. Okay? Again, this is very fundamental, very important for the connection to be established. The fourth thing that this has is called the SI scheduling info. What is SI? System information scheduling information. Okay, so scheduling info. Okay, so earlier in LTE, what used to happen is, earlier LTE used to send SIB, in addition to MIB, after you decode your MIB, you had to decode SIB1 and you had to decode SIB2. I think also SIB3 also. I think so, but SIB2 for sure you had to decode. Okay, there's a lot more information that you had to decode. So what they did in a 5G NR was, in 5G NR, they rearrange what is there in SIB1 and SIB2 and other things. Okay, they categorize something called as minimum system information, minimum SI it is called as. Okay, so the minimum system information is the information that you required for a UE to lock onto the cell. Okay, to lock onto the cell and do patch. When I say lock onto the cell, essentially it means you can be able to do patch. Okay, so that is exactly what is there in MIB and SIB1. Okay, and there's a lot of other information that you require. Okay, for example, timing information, UTC timing. Simple, I'm just giving an example of UTC timing, emergency call information, so much other information that will be there. Okay, so these constitute the other SIBs. There are some, for example, you can say SIB2, SIB3, SIB4, SIB5, SIB8, SIB9. Okay, I think SIB9 is for example, the GPS and the UTC information. Okay, so all this other information, what happens is in this SIB1, it is told where this information is scheduled. Okay, there are multiple ways in which you can obtain the SIP, other SIPs. Okay, one is some of the SIPs are periodically broadcasted at a much more lower rate than SIP1. Okay, that's told here. It's told how this is done. Okay, a second option is UV can actually ask the network, say, please transmit me SIP9 message, and the base station transmits. This is unlike LTE. Okay, so the UV can actually tell the base station that, okay, transmit SIP3 information, SIP4 information, or SIP9 information. It will do that. Okay, so how those SIP messages are configured, what are the things you can request, what are the things that are broadcasted, that is there in this SI scheduling info SIP message, SIP1 message. Okay, so this is one of the major distinction between LTE and 5G NR, is that there's something called as minimum system information, and that is only MIB and SIP1. So if you decode MIB and SIP1, you should be able to lock onto your network and do crash and other things. Okay, and there's other system information that you can get, based on what is your requirement and other things. Okay, it's not very critical for your survival in the network. Okay, so that is called the SI scheduling info that is there in your SIP1 message. Okay, and the most important thing is the serving cell config common. Okay, so this is where a lot of the things that we require are there. Okay, so we will. So any question till now? So I'm just going at a very high level through all these messages. Okay, just to know what is there, what is not there. Okay, I don't expect you to remember any of these things anyway. Okay, so the serving cell config common has, if you look at this, so this is part of SIP1 message. So this is serving cell config common. So this serving cell config common SIP has multiple, it's a structure that consists of multiple more entities. You see downlink config common SIP, uplink config common SIP, and there's some for supplementary link, if you have supplementary link, but you can forget about that for now. And there is TD uplink downlink configuration common, and some more things. Okay, SSB position in burst and other things. Okay, if you focus on the TD uplink downlink configuration, this is the first time it tells you about, see, one thing is you can identify whether you are in TD or FDD by looking at the band you are. Okay, you are in which band, based on that you know it's TD or FDD. Once you know TD, you should know how many slots are uplink, how many slots are downlink, where is the transition and other things. Okay, so that part is given by this TD uplink downlink config common. Okay, we will do this in great detail in the next, after this I'm going to teach you in this particular part. Okay, but you see it has all the things. It has what is uplink downlink patterns, how many downlink slots, number of uplink slots, all this information will be there. Okay, so once you decode this SIP1, you understand the TD uplink downlink configuration common, you will understand which are the uplink and the downlink slots. Okay, any question here? So the next thing I'm going to look at is the downlink common config SIP. Okay, so in this serving cell config SIP, this downlink config common SIP. Okay, in this downlink config common SIP, there are two important things. Okay, one is called the frequency info downlink SIP. See, until now, what did we get? We got offset to point A. Okay, we got offset to point A. So offset to point A is nothing but offset from your SS block to the point A. Okay, but we still don't know where your carrier is. Your carrier can be anywhere, because you have only synchronized to your this raster, synchronized raster. You don't know anything about the channel raster as of this moment. Okay, that is given by, so of course the one thing is offset to point A is also here. That you should remember. See, offset to point A is this. That's offset to point A parameter is here. In addition, 1 minute. In addition to this, so this lists the carriers that are there. Okay, so if you have only, it's a TD system, there's only one carrier. So it will tell you offset to the carrier. At what point is the center frequency of the carrier there with respect to offset to point A. Okay, what is the carrier bandwidth? What is the subcarrier spacing? All this information is there here. Okay, this is there in the frequency info downlink SIP message. Yeah, so this is the picture I just showed you. This is offset to the carrier. This is your resource grid. Offset to the carrier tells you where is your lowest resource point with respect to point A. Okay, so when you decoded your SSB, you know, and you know the offset to point A. after you decode your SIB1 message. Yes. So once you decode your offset to point A, from there you can decode the offset to carrier, and from there you find the CRB0. Is that fine? Okay. And there's something called the BWP downlink common. Okay. So BWP downlink common is the first initial bandwidth part that is common for all the UEs. Okay. This is the first thing that the UEs will decode. Okay. So, I mean, this is it's not the first thing that the UEs will decode. So essentially, this is what you say. This is a common bandwidth part for control information that flows to all the UEs. Okay, this is something that is required. So essentially, there's something called bandwidth part in this, and the bandwidth part has it actually tells you the location and the bandwidth of that bandwidth part. Okay, again, we'll do this in detail when we do the resource indicator values and other things in the coming classes. Okay. Similarly, there's uplink config SIB. In the uplink config SIB, one of the important things that is there is, of course, is frequency info uplink SIB, because if it's an FDD system, you require both the frequency info for downlink and the uplink. So the uplink frequency info will be here. And in the BWP uplink common, there is the RACH configuration common. Okay, so the PRACH parameters where you can transmit uplink and the downlink info, I mean, where you can do the uplink PRACH is given in this BW bandwidth part uplink common. Okay, so I mean, those of you interested in very, very detail, you have to go through all this. So I have just summarized all of this in one slide like this. Okay. So, I mean, it tells you which of this, I mean, what are there in SIB1. I mean, I put only the important parts. The other parts I have not put, the other parameters I have not put. Okay. So in the serving cell config is where you have the TD uplink downlink config. In the uplink config, you have the frequency info uplink and you have the bandwidth part common. In the bandwidth part common, you have the PRACH. Similarly, in the serving cell config, you have the downlink. In that, there's frequency info downlink. In addition to downlink bandwidth part common. Okay. So, I mean, I don't expect you, I mean, just so essentially, you should know where to look if you are looking for specific parameters. For example, you want to understand where PRACH happens, which config is PRACH. You immediately should understand that it comes in SIB1 message. Okay. You should understand that it comes in SIB1 message. Okay. In the SIB1 message, there's uplink config common SIB and the PRACH is there. Okay, that's what I want to understand. Okay. So with this, I'll conclude SIB1 message. I mean, there's no point in doing looking at the message, individual messages, and understanding what they are. I mean, if you're implementing something, you have to look at that in great detail, but otherwise not required. So what are the things that you take? What are the summary of this whole SIB1? Okay, you decoded your MIB. Once you decode your MIB, you will be able to decode your chord sets. You know the exact location of chord set 0 based on some table lookup and other things. Tables, we have seen that. And once you decode your chord set 0, you will know the PDSCH location, which contains the SIB1 message, and the SIB1 message can be decoded. In the SIB1 message, there are lots of important information so that you can proceed to the next steps of PRACH and other things. Okay. So, I mean, the SIB1 is a very, very big resource, IE, information element, that consists of, some of the things I have highlighted in this picture. Okay, does it make sense? Okay, so we'll go ahead. So now I'm going to start a little bit on TED structure. Okay, because there's the next important thing that we have to learn. Once I do the TED structure, then we'll go into PRACH. Okay, then we'll do bandwidth part. So to do the TED, first let's understand what is the TED structure in 5G NR. There are some things that will be not clear because we have to understand DCA formats for that. But let's understand as much as we can and proceed further. Okay. Any questions on SIB1 messages? I'll put these slides on the this thing today. Any questions on the SIB1 messages? So I mean, essentially, effectively, what I want you to learn from the SIB1 messages is important parameters are there, and some of the important parameters like PRACH, TD, and other things are there in SIB1. That's all. And then you can decode SIB1 once you decode your SS block. Okay. So next, let's go into TD structure. So the TD structure is very important. Here is where we are going to learn about timing advance, okay, and other important things. Okay. So I'm just a brief summary. So NR, okay, NR is 5G NR provides a lot of flexibility for TD. Okay. So one of the first things that we saw in the previous slide is that TDD is configured by RRC parameter, which comes in SIP1 message. And we saw the SIP1 comes in 160 milliseconds or that frequency. Okay. In addition to that, there are other places where TDD is configured, something called DCI. Okay. So what is DCI is downlink control information. Does downlink control information occurs at every slot. Okay. So you can actually control the TDD structure at different time granularities. One is you can do, you can keep something constant for an entire time duration. You can change the TDD structure at the RRC level, which happens about 160, hundreds of milliseconds. You can do it at the DCI level, which happens few microseconds. Every slot there's a DCI. Okay, so it provides huge flexibility in terms of TD, what do you say, configurations. How you can change your TD configurations in the network. Okay, so many more options than LTE. To understand this, to put this in perspective, if you look at LTE, there are only 7 TD configurations that are possible. So these configurations I have highlighted here. I just took this from a textbook. There's configuration 0, configuration 1 up to configuration 6. You can see that now. And there are different downlink, uplink, this thing. Different DL-UL ratios. Okay. See, the problem with this is of course very good. In terms of implementation, it's very nice. But the problem with this is you're fixing your downlink and uplink transmission ratios. Okay. So depending upon your time, location, scenario, and all this downlink and uplink traffic ratios change. Okay. So, generally you have more downlink traffic and lower uplink traffic, but it may change depending on where, for example, in a place where a lot of people are uploading their videos and other things, the uplink might take a hit if you have a lot of downlink and no uplink. Okay? But later parts of LTE, they try to provide some flexibility in this configuration. Again, something similar to NR, but it didn't work out too well. There's something called flexible TED, but it did not work out too well because by that time all the networks were implemented and changing this stuff is very difficult. Okay, so even now LTE means only these fixed 7 configurations. So I want you to focus on a few things. Okay, let's just look at this. Let's just take configuration 0. It doesn't matter. Configuration 0. So this is downlink. So this is from the base station perspective. Remember this from the base station perspective. So downlink means base station is transmitting. So when the base station moves from transmission to reception, there's a gap. There's a small gap here. You can see the white gap here. No? There's a small white gap. Maybe I'll put it full screen and put a laser pointer. Just hold on. Yeah, this is a small white gap here. Okay. And this is the uplink. Uplink means essentially the base station is receiving. When the base station is moving from reception to transmission, there's no gap. Okay. Only when the base station is moving from downlink to uplink, where that means moving from transmission to reception, there's a gap. Okay. So we will let's understand why this is the case. Okay. It's a little bit counterintuitive because when you move from, when you're actually transmitting, you actually use your power amplifier. So in base station, the power amplifiers are very large generally. Okay. There are a few tens of watts, 30 watts or 40 watts, depending upon the configuration. Okay. So generally what happens is when you have a power amplifier such high power, switching it on takes some time. There's a ramp up time for this power amplifiers. On the other hand, switching something off is very fast. It happens in a few microseconds, less than few microseconds also. Okay. But what they have done is they have provided time when you're switching it off and no time when you're switching it on. Okay. Is this clear? Is my question clear? Why did they do that? Okay, let's try to understand this. Let's try to also understand how they take care of the switching on and switching off times also. In the next few slides. So did you understand this? Any questions before we proceed?
Sir, can you again explain that switching on and off over here? Because see, in uplink, after uplink it is a downlink, there is no time lag. But just now you have said that there is a big power amplifier at the BTSs over there.
Yes.
So there is no time lag, but it contradicts what you have said, sir.
That's what you are seeing. But the question is, how do we take care of that? Okay, that's what I'm trying to explain. Okay, so if you look at this, I mean, generally when people implement this, people think that, okay, power amplifier takes some time. Maybe it takes about 100 microseconds to ramp up. Okay, so you require 100 microseconds. So when you are increasing, so you cannot switch on your power amplifier also too much earlier, because once you switch on your power amplifier, what happens? It leaks into your receiver, and receiver gets interfered. Okay. So there's a little bit counterintuitive on why they did this. That downlink to uplink transmission, they gave a gap. This uplink to downlink transmission, they did not give a gap. Okay, let's understand this. Let's understand this in detail. Okay, we will take a couple of slides to understand this. Okay, that's one thing. And by the way, in this LTE, this particular slot where there's a transition from downlink to uplink is called a special slot. This is called a transition slot. Okay, so you see a part of this is downlink. A part of that slot can also be used as uplink. Okay, that's called UPPTS, and this is called the guard period or the transition period. Okay. Anyway, these concepts are now, much more refined, better in LTE in 5G and R. We'll go to that. Okay. So first, before we go and understand this timing diagram, let's understand this. Let's understand timing advance first. Okay. So on the top, I have just put a base station transmission. So there's a transmission. After transmission, I'm giving a gap, and then I'm just starting my base station reception. Okay. So remember, base station is the master in the network. Okay. Finally, base station is what dictates everything. You should always remember that. Okay. So base station is going to transmit, and base station is going to receive from this point. Okay. So you understand now how OFDM reception works now. Once you receive from this point, what you do? You remove your cyclic prefix. You take your 4096 samples, pass it through FFT, go on processing. Next, remove your cyclic prefix. Take 4096 samples, pass through FFT, and so on and so forth, and that's how you receive. Okay, so base station, it's the job of the UV to make sure that the receptions are within the cyclic prefix. Okay, within the cyclic prefix that is there. Otherwise, the UV will not be able to get decoded. Okay, so how does this happen? Let's see. So first, let's start with the transmission part. So base station is transmitting here. So I'm taking two UVs. One is called the near UV, which is close to the base station. Let's assume it's a little bit closer to the base station. And one is the far UV, which is a little bit far away from the base station. Okay, I'm going to just remove. Okay, so the base station is transmitting at time t equal to 0. There will be some time for the propagation to happen, maybe a few microseconds. Okay, depending on where you are, few maybe half a microsecond or so, depending on where you are. Okay, so the UV will receive at this point. The UV near UV1 will receive at this point. Okay, this far UV is a little bit far away, maybe this cell edge. So it will take more time for the same base station transmission to reach it. Okay, that's the gap. You see, there's a little bit more time. Okay, the UV received here. Okay. Okay, so now what happens after some time? The base station, the UV received it, then the UV should transmit. So wherever the UV transmits, the UV should make sure that the UV transmission that's as received by the base station should be aligned with this red line. Okay, so what does it do? If it's able to find out this gap, then it will start a little bit ahead. The UV will start transmitting a little bit ahead, so that by the time this first symbol reaches the base station, it will align with the base station reception. Okay. So just to put this on the perspective of UV2 will start a little bit much more ahead. UV2 will start there, so that UV2 is received at this point. Is this clear?
Yes, sir.
Okay. Okay. So now you see, when the base station is moving from transmission to reception, you require this gap. Why do you require this gap? This gap is mainly to help the UVs to advance their transmissions.
So if it misses this slot, then it will wait for the next BS reception, sir.
So what can you repeat it, please?
The example UE2 is unable to send this much early, for example.
Yeah, then it will do it in the next slot. Yeah, it will do it in the next uplink slot, the next uplink slot. Yeah, that's correct. Absolutely correct. Okay, I'm not taking that into account. I'm just here just showing because it's easy to show in one picture. I'm showing it like this. Okay. So you understand the reason why there's a gap between the transmission and the reception is mainly for the UVs to do timing advance so that their transmissions are aligned with respect to the base station reception. Is this fine? Okay, you can immediately see that any question?
Sir, is there any case in which BS transmission and UE2 transmission can overlap? No.
Sorry, is there any case in which UV transmission to and BS transmission? Yeah. So we should make sure that that's why the cell size is an important parameter. Okay. You should make sure that this transition time is larger than your what do you say? What will happen? This should be twice the round trip delay. Okay, this delay plus this delay should be less than this gap. Okay, if you call this as X, this gap is X, and this advance as Y, X plus Y should be less than this transition time. Does it make sense?
Yes, sir. Yes.
Okay, so that is that. So if you have very large cell, then this transition slot also should be larger. It's very important. Okay, see, some of this can be absorbed by the CP, but you don't want too much of that because otherwise, what will happen is your multipath resilience will go down because your CPs you are mainly using it to take care of your multipath rather than what do you say, so much timing advance. So this timing advance should be absorbed as much as possible, should be absorbed by this transition slot. Some of it can be absorbed by the cyclic prefix. That's okay. Okay, so you can immediately see that you don't require. Sorry. The next base station transmission can start that point. You don't require any gap between them. Okay, I mean, forget about the power amplifier for now. The base station will again transmit here. You can think of this happening here. Again, there will be delay. This is what happens. So there's no gap between base station reception and to base station transmission, whereas there's a gap between base station transmission to base station reception. The gap is not for PE or anything. It's mainly for timing advance. Okay, so this is what confuses people a little bit in the beginning that, okay, why is there no gap from the reception to transmission and why is there a gap between transmission and reception? The main reason is that it's because of timing advance. This is called timing advance. Okay, so how does the base station know what is the, I mean, this particular gap, how much will be there, how much this advance should be there? That is what happens in PRACH. When we do the PRACH, we'll understand. The base station will actually compute how much ahead the UV transmission should start so that it can reach it in correct time. Okay, that base station will compute that and tell the UV actually. Any other question? Okay.
Hello, sir.
Hello, please. Who is this?
Sir, Asif here.
Ashif, please tell me.
Yes, sir. So in this case, the channel should be reciprocal, right, sir? Reciprocal in the sense that.
Why should I mean the delays are reciprocal? I mean the time that goes from A to B will be almost the time that goes from B to A.
So you can see some another channels statistics what BS sees, right, sir?
Huh?
So while transmitting from base station to UV, there is some delay. So some channel statistics is there. So when UV is transmitting, so channel statistics may change from the U perspective, right?
See, channel statistics may change, but the main path will approximately be the same delay. Now, delay can't change because the distances are the same.
Okay, okay.
A to B is equal to B to A. Na? I mean, I understand this channel might change. There may be some deviations, but the delays won't change so much.
Okay, sir.
Okay. Anyway, this timing advance is computed by the uplink transmission only. I'll tell you how the timing advance is computed. I mean, when we do the PRAT, you'll understand. Do we transmit something? The base station understands how much ahead it came. Based on that, the base station tells, okay, it came about 30 microseconds earlier. So you next time, it came 30 microseconds later. So next time you advance your transmission by 30 microseconds.
Okay, sir.
Okay. So in the next class tomorrow, what I'll tell you is, I'll also tell you how the PA transition time is also incorporated in this. It's actually pretty straightforward. I will draw the diagram and show you how the PA transition time is incorporated in this, is absorbed into this. Okay. I will do that. Okay. And then we'll go ahead and look at what are the different TD configurations that are possible in 5GNR. We will go through that and close that up. Okay. Cool. So I'm hoping, so I'll just stop the recording and